Okay, so bananas have a half-life of 4 days. So I'm going to draw a little picture. So we're going to start off with a full banana. And during a time period, we're going to have half of that banana remaining. And then another half-life, we will have simply a quarter of that banana remaining. Now this process will continue forever. So the fraction of the banana that we start with is 1, then we have 1/2, then we have 1/4, and again this goes on forever. We want to think about it like on a number line. So we're going to start off with grams and time. And if I draw a number line, the number of grams we're going to start with is 100. Now that number of grams is somewhat arbitrary, and that will be at time 0, and the number of half-lives, HL, that have occurred is 0 half-lives. Now after 1 half-life, this happens every 4 days, so that will be 4. And if I have a half of what I started with, I will have 50 grams. Then I will have 25 grams. That will be my second half-life, and that will be 8 days. All of these patterns continue on forever. So now let's take a look at a couple of word problems. So let's start off with how long until 3.125 grams. How long until 3.125 grams? So we're going to be giving you formulas. So the formula we're going to give is F future value equals present value times the rate to the exponent of lowercase t over capital T. Capital T is the 4 days, the time for the growth rate to occur. The rate is a half-life. So the future value is going to be the given 3.125. The final is going to be, the present value is going to be 100. The rate is going to be a half for the half-life that we discussed earlier. Lowercase t will be t, and the time for the growth rate to occur will be 4. So now I want to type into my calculator y1 equals this and y2 equals this. I could, for example, clean it up a whole bunch more, but right now I'm just going to type it in as I see it. Remember, we don't have a t variable on the calculator, so we have to use x. Now, I know that my y values are going to start up at near 100. And I know my intersection is going to happen at 3, so I need to change my window. So when I make my graph, I'm going to go right away and make my y maximum 100. And I'm going to leave all of the rest on the regular 10 by 10, and I'm going to press graph. So I can see some of my graph, but I can't quite see the intersection off to the right. So I'm going to go in and I'm going to change my window to have a x max of, I'm just going to guess, 30 graph. So now I have both graphs and I can see that they do intersect. However, it's tough for me to see where the intersection is. So I've realized that my first line is so low, I'm going to go back in and change my window in y just to be 10 and 30 in the x. So my y max is going back to 10. Then I can clearly see y equals 3.125. And the other side of the equation I see coming down like that. And I have my intersection, so I'm going to press second calc 5, enter, enter, enter. Notice the y value is the same as the point we got. We get 20,3.125. That was one of the equations. Now, we're not working with x, but our answer is t equals 20. Now in the notes, you can see how I've continued that number line, and you can see how it all actually works. So I'm going to leave that number line set up, and I'm going to do another question based on that number line. So how much after 28 days? So now a similar type of question, but not exactly. So how much after 28 days? So let's get that a little bit bigger. Perfect. Okay, so I'm going to start off with the same question that I was working on, the same equation we were working on before. Future value equals present value times the rate to the exponent lowercase t over capital T. So how much after 28 days? Well, that's the future value that I'm looking for. My present value is 100. We're starting with that each time. My rate is 1/2 for a half-life. Now it's giving me 28 days. That goes on the top of the fraction. That is the time that has occurred. And on the bottom of the fraction is the time it takes for the half-life to occur. Now this question I can simply just type right into my graphing calculator, and I get 0.78125 grams. Remember to use your units. I think I may have forgotten the last question. Remember to look at the notes. All of these questions are worked out in the notes as well. Let's take a look at another question that we could be asked. So, for example, how long until we are 256th of what we started at? So I'm going to start off with the same problem. Now, earlier I said that the present value was arbitrary. Now, what I meant by that was it matters, but if I want to have a future value of 1/256th of the original, that means that my present value is simply just 1. I could have made the present value 100 and then divided that by 256, but I want to show different methods. So again, the rate is 1/2 to the exponent lowercase t over capital T. The 1 in front goes away. Now I'm going to do some grade 9 exponent laws. So 256 is 2 to the exponent 8. So if 256 is 2 to the 8, I know that 1 over 256 is 2 to the -8. Again, remember, I said before we're going to be doing the 7.1, 7.2 rules back and forth all over the place. We need to very quickly be able to recognize that. Now 1/2 is simply just 2 to the -1. And excuse me, I forgot to put 4 on the bottom of the fraction, to the t over 4. Now on the right hand side I can simply multiply my exponents together, and then I have the same base, so I can make my exponents equal to each other. And if I times both sides by -4, I get t equals 32 days. Don't forget your units. So notice you can see that question in the notes as well, all on the number line. So sometimes we'll be just typing into the calculator, sometimes we'll be using the graphing calculator, sometimes we'll perform change of base, and in the next chapter we'll be doing logarithms. So what if I just wanted to graph this thing all by it myself? Well, for the first thing we're going to do is we're going to remember, how do we graph things? We graph things with a table of values every single time, and I always say x and y. Now I know this is just going to be an L graph from experience, but I'm not working with x, I'm working with time, and I'm not working with y, I'm working with grams. So at time 0, I have 100 grams. So I can mark the y-axis and the x-axis, and I have the point 0, 100. So I can mark 100, and I can label the points 0, 100. Now my next point at 4 days, remember my half-life is 4 days, so that is what my table of values will go up by, and that will be 50 grams. So I can mark 4 on the timeline, I can mark 50 on the y-axis, and I can put my point there, and I can label my point. And then it continues. After 8 days, I have 25 grams, so that will be 8 days, and that will be this point right here, and let's label that point 8, 25, and let's just do one more point. So one more time period will be 4 more days. For 12 days, we'll have half of that amount. Let's mark the y-axis, and that point will simply be approximately here at 12 days, and then I can draw my graph. So we have an exponential function that we're going to see graphing a little bit later, but if I just try and follow this as best as I can, I'm going to go down like this, and remember, I don't get to the x-axis, I get really, really close to it. So if I were to graph it all the way up till 32 days, I would be able to get the same answers as we did before. So that's an example of a full word problem and how they work. Lots of the times the graph will be increasing if we're putting money in the bank, or decreasing for any other reason. So now we're going to take a look at some word problems with just the math involved.